Hey CB, good evening. How are you doing?
I'm doing great, Amit. How about you? Thanks for asking.
Yeah, I'm doing good too. It's been long since I thought to connect with you and discover what's happening in the latest and greatest things happening in the world of machine learning, data science, and the much hyped word of today, Gen AI. So,
Correct.
most welcome to this podcast. And the core intent behind running this podcast is to talk directly with professionals, data practitioners who are there on the floor solving problems, real world problems in their day-to-day lives, and share that experience with the world outside, especially the working professionals who are either working in data science, maybe they're in a little early in their career, 0 to 3 years of experience, or professionals who are little senior and maybe they're working in a different domain. And the goal would be to help them understand what's happening, what's the latest thing happening, what are the latest challenges which are being faced, how are the workflows being changed while we leverage ML, DS, AI to solve business problems. So to begin with, let me introduce a very short introduction of CB for our audience, and then I'll let CB talk a bit about his experience, and then we'll move on to a bunch of interesting questions which I have for CB. Right, Siri. So let me take a quick stab at your experience. So I'm just referring to LinkedIn. Although I think we both know each other from the days of Fractal, we both have been Fractalites, and
Yes,
although worked in different projects. But I think somewhere the passion of teaching, upskilling is kind of connecting us. I know you have been part of Fractal, taking sessions back in your days at Fractal. So that is how I always admired the kind of intent you brought to share your knowledge always. You always had this knack of sharing. So, talking quickly about your work, I think you have almost close to a decade of experience in the industry. And you started off with, I saw that interestingly, you did a ML tutoring role you did pretty early in your career. And then you joined Fractal. And I would really like to talk a bit about your experience at Fractal, where I see a few very interesting work. For example, I could see your stint at Fractal as an AI engineer, and this is 6, 7 years back when AI, even the AI engineer word wasn't that much popular, right? So while we know that at that time, today everybody is talking about being an AI engineer, but I think you had the role of AI engineer back in those days in 2018. So, and especially your work which you did while you were in UK, the upselling CLTV project, the customer retention churn project, right, using GCP. I see that it was a pretty, I would say it was a complex one where we had to predict, say, upsell models. We built upsell models for 20
correct.
products, 10 million customers across 3,000 retail and call agents. So why not like you talk a bit about how was AI engineering different 6, 7 years ago, or I would say pre-ChatGPT era? What were your workflows? How did you approach ML and data science in those days compared to what has happened post-COVID, and it is post-COVID and post-ChatGPT, where everybody is talking about like, okay, the entire world of DS and AI has completely gone upside down. So there's a lot of hype around, but I would like to know the real thing from you, Sibi.
Thank you so much, Amit, for this great introduction and so many things to reflect upon back then, like how it started. So actually, like the journey to reflect upon. So I was very fortunate enough. I started as a data engineer, to be honest. So starting as a data engineer made me realize like we need to understand the domain end to end so much. So had I directly jumped into data science, right? Maybe I might have not got the complete flavor of how the data is scattered, what are the data models need to be developed, and what are the different granularities need to be identified.
Right.
So I was very fortunate enough to start as a data engineer, where I was able to get the various complexities and the various formations of data, where it's at present, how the ETL transformations happen, how do you process that in real time. So that's the first Lego block, right? The basic Lego block is to understand your data first. So you may be a bigger data scientist, but at the end of the day, you should be able to know where your model is failing, right? You need to understand the data first. So that's the first point that I took up in my journey, like that helped me in my data science journey. And the second part is basically about understanding the whole pipeline, right? So basically, since you are, let's say, like I was fortunate enough to be in a churn model project. So here, at the end of the day, we are going to solve a simple churn model using a, let's take an example using a supervised learning technique. So you know how a decision tree work, and you're going to apply a decision random forest or XGBoost kind of technique to it. But it is not just solving a data science problem, right? So here you have a data engineering problem, you have a whole data operations here, you have ML operations here, you have a infrastructure problem here, and then you have to deploy a churn model. So since I was into a flavor of data engineering plus ML engineering, all these flavors, all these Lego blocks combined helped me in building a data science solution. So it's like a data science skill set is something, let's say, okay, he or she might be well versed with mathematics or Python or all the MLDK or ML packages, scikit-learn, PyTorch, TensorFlow, all these packages, right? But it is also beyond that, right? So whatever we learn it through Udemy or Coursera, so they all tell you how an algorithm will work, but to deploy an algorithm in real time, so at first anybody can build a churn model using looking into a research paper, and you can try using that same algorithm, but how is it scalable? How can I deploy it across different regions? How can I make it as a generic solution? This is where all the ML algorithms and all of us fail, right? So all my big data knowledge helped me leverage all the data science fundamentals.
Just hold
So
on to
that
this
is
point. So when you said, my impression of a fresher data science graduate, right, as somebody who's doing data science, maybe from a university, college, or maybe some educational, some ed tech or somewhere, when they come out, they would say, okay, we have done a project, a data science project. And majority what I have seen is they end with a Jupyter notebook. They have a bunch of data set. Maybe they will have some CSV data set. They will consume. They will try to create a training set and test set, and they'll kind of do some sort of k-folds validation, some sort of thing. So people do follow, say, a machine learning workflow, but I think that's a very static one snapshot of a very big or a very broad set of tools and principles which need to be followed to make a solution work. So
correct.
what I would like to ask you is to kind of start from the top, where what do you mean by an ML model working? For example, I'm very clear of what do you mean by a dashboard working, a BI dashboard working. I'm always clear of what do I mean by a software application working. But when I say an ML model working in production, can you give me a picture of how an ML model working in production looks like? Maybe in your previous domain, which was more into retail e-commerce, or in your current domain, which is healthcare. If you could give a picture, what we'll try to do is we'll try to funnel down and try to come down to a point where say, okay, this was the big gap between when you say that, okay, I'm a notebook ready data scientist, to a point when you're saying I'm production ready data scientist. Can you reflect a bit on that?
Okay. So of course, yeah, even after the chat GPT era, like building ML models are not that complicated, right? Anybody can just, if you know the data, you can easily build it. But ideally, it is not just that, right? So you will have to know. So when we are building a productionized ML model, right? So you need a lot of things going in and hand together, right? See, the first step is basically to understand how the data behavior is going to reflect in production data, right? So I think almost after 2020, most of the ML models were hit with the COVID issue, right? So the model have never seen the natural phenomena called COVID. So because of that phenomena, I think all the sales got impacted, revenue got impacted. So all these direct indicators which were dependent on this natural phenomena like COVID got impacted. So the first step is basically understanding the drift in the data. So you need to know like whether a data scientist should know how is the drift is going to affect the model. So we have to ensure a mechanism that could take care of all these issues. Like let's say if a categorical feature has a newly added variable, whether I am in a better position to use a chi-square text to determine it, whether will that be determining it, all these logs should be logged in a telemetry dashboard. This is how a real-time ML dashboard looks like, right? For this week, model ran, and this feature called, let's take an example, family. So it had three categories: household, single, married. So a new feature, new category type came in. So that is the newly added category. Then this is how it is going to impact my model performance. So that's the first basic thing, right? You need to have a basic dashboard which has all the data drift in it. And once you're done with the data drift, we also have something called model drift, right? So every week on week, we have a model performance, right? Let's say I build a simple churn model. Churn model is nothing but whether it's a 1 or 0, it's a binary classification. So it is the model will give you some churn probabilities. Based on those probabilities, it is for the users to decide, that is the stakeholders to decide whether let us identify those highly risky customers. So their job is not only the high risky customers, right? So from the ML perspective, what is the next best action I can take on those high risky customers? So our work does not stop till here, right? So we are not stopping our work here. So we will have to segregate them into cohorts, basically high risky cohorts, low risky cohorts, and medium risky cohorts, and then do some even another analysis on those high risky cohorts. So that is where we do something called simulation, right? So your ML production dashboard should know to simulate certain features. So let's say for a simple example in a layman terms, let's say I am going to know person X is going to churn out of the system. Now, how do I retain him? Let's give an offer of extra 100 rupees. So this is hard simulation. Your ML dashboard should know your high risky customers and also know what kind of techniques I can add on top of it so that the stakeholders are convinced with it. So that I can send a message that, okay, that is the action I'm taking. Sending a message saying, hey, you are eligible for a offer of rupees 100. So please use it before next week. So this is one templated message we are doing it. So these kind of gaps, this is how a model looks in real time. And finally, once we have the model drift, right? So it is for the data scientist internally. So once the model performance is getting corrupted, so basically, once we correct the model performance, how do I retrain the model, right? What is the next best thing to retrain the model? Should I wait for 3 months? Should I wait for 6 months or 1 month? So now the problem with retraining is when we are using packages like MLflow, maybe we can talk about it in the upcoming questions. But the what is the associated compute cost to retrain a model in a production without any human intervention? So that is another challenge tied with it. So basically, for a data scientist standpoint, it should talk about data drift, model drift, and basis drift.
Right.
Yeah, Amit, am I audible?
Yes.
Sure.
Yes, you're talking about model drift.
Yes. So these are the basic things the telemetry dashboard should look into it. So how is the model performance dipping? So that week one, let's say the accuracy, precision, recall, F1 score, how it is going to dip with the current performance. So one thing the data scientists are very, very clear is the ground truth may not be available immediately. So this is how the data scientist should be preparedness for the models actually. For since the current scope we are talking on the ML models, so the ground truth will not be available immediately. So it might take 2-3 weeks to come, or maybe 1 week maximum to come in. So we should have a good telemetry dashboard which captures all the data related information, both statistical test and the model related information, all these things into a better picture that helps the data scientist.
Okay, so what we'll do is awesome. So, Cibe, what I understood, what I'm doing is I'm just going to share my screen and I'm just going to jot down few of these terms which you mentioned. Okay,
Okay.
for simplicity.
So before that, Amit, does this make sense from a data scientist user who sees all these telemetric metrics in the dashboard? Like, is it relatable?
I feel so. That's why what I thought is I'll just jot down few of the things so that we are also typing something and people can see something written rather than just being able to see our faces. Okay.
Yes.
Okay. Okay. So, CD, as I was hearing you, what I could figure out was that suppose if I put up, say, stage zero, okay, this stage zero is when I am a beginner, say I'm a newbie data scientist, okay, who say builds the churn model
Correct.
on a Jupyter notebook.
Yes.
Okay. So I built this Jupyter notebook with all the standard workflow to follow and say, I came up with an accuracy score and I came up with the outcome where the customers are being labeled as 1 or 0. Okay.
Correct. Yes.
That's the outcome which a novice will bring out. Okay.
Perfect.
So now from here, if I go back to uh, old times, okay, how would this notebook, right, be converted to a working production model? Let's go those days when there was no chat GPT, no AI, no all those things. We were doing plain old ML. At that point, I remember we used to create say, pickle files or a few of those things. We had to convert them to Python. Can you throw a light on some light on that? We'll try to build these stages for pre-chat GPT era, and we would then again reattempt by looking at it from the modern perspective. Do you think that's
Perfect.
the right thing to do?
Perfect. So basically, at least one good thing I wanted to bring in is I was also fortunate to join during the year of 2015-16 times where on-premise was also into play. Like I was not the person who was directly jumping into cloud. So when I started my first machine learning model, that was in Spark actually. So the users had created a separate Spark environment and we were accessing it into a virtual machine actually. So
Did we had
that was
mlib libraries? Were you using mlib libraries, Spark mlib libraries for doing
yes,
all
yes.
this?
So we used the Spark ML, yes. So we were using all those things. So that is where I'm coming from. So I would just quickly tell those three basic things what we did. So during the days, right, 2018, 17, when we productionized the ML model, so we looked into three different main concepts actually. So one is from the data standpoint, second one is from the infrastructure standpoint, and the third one is from a model standpoint. So basically, your data standpoint is the first thing. Like, let's make sure, like, how am I going to read the data and how am I going to store the data?
Right.
Because for all the data science projects, right, you will have an input data source, output it is getting stored into some derived form. So from X to X dash, I'm going to store data from one format to other format. So
Hmm.
that is the first thing. Then basically from the infrastructure standpoint. So infrastructure standpoint is nothing but basically how do you want to build this application, right? So do you want to take it as a cloud agnostic or is it an on-premise or it is just going to run it in local VMs? Basically the trade-off between a cloud versus on-premise solution. So that was the second point. And the third one is from the model perspective. So from the model perspective, the main part which we wanted to try is how do you want to deploy the model and where do you want to store it? So that I have one tool which can support both my data seamlessly and model seamlessly.
Hmm.
So that is where we started with the basic creating a Spark environment and accessing through a Citrix workflow or creating a virtual machine and connecting to a server and then try running it. So this is the most traditional way it was happening till 2017. But suddenly 2018, everybody start now we are in a hype of LLMs and NLP too much,
Right.
right? During that time, 2018ish, every organization started migrating to AWS, Azure, GCP. So I think the LinkedIn was jam-packed with all these posts in 2018. So that is where the style of changing the narrative of deploying the models took a shape. See, whatever you are going to spend for ETL transformation, try to leverage that for model as well. Example, let's say I want to spin up a simple cluster, Spark cluster, and run a data engineering job using Spark. Then why can't I use the same cluster and run and deploy my model using Spark itself? So that was the basic assumption. So what you did for data, do the same for model. That was the basic advice was thrown that time. Since everybody started using the cloud, first started, like they started with how the on-prem to cloud conversion. Then is where the cloud advancement happened. So then they started talking about serverless versus non-serverless.
Yeah.
Serverless means you don't have to create a with compute instance like Databricks, and then you don't have to spin up a cluster and do all those things. All you need to do is you will have to do specify the configuration, submit the job, it will automatically do it. So this Vertex AI in Google Cloud, it does that.
Yeah.
With Databricks in Google Cloud. Databricks in Google Cloud is nothing but you are going to create a compute instance, you are going to manage it, you are going to do that. So that is where, so already we were in the on-prem versus cloud. Now within cloud itself, we had this distinction of serverless versus non-serverless. So with all these base inputs everywhere throwing all together, another issue also came in. So those days we had a terminal, create shell scripts and run all the codes. Now again, the advancement went into the orchestration side as well, whether to use a Airflow or a data factory or a control M or a glue. So many solutions came in market. So that was the final thing. So for starters, Databricks was offering everything to us. That was one common goal of Databricks actually. They made sure you have a Databricks file system to load all your files, even a huge files. And you have this, you can easily link to a blob storage in Azure, and you can load the necessary data, do the ETL pipelines. Then you can also save the model even in the Databricks file system, or you can put the model in the file store, or you can easily integrate ML flow on top of it. So you can configure all these various flavors. So that is where ML flow, Databricks all gel together, and then making the ML models itself more easy and sufficient. It's just that if you do one click, your current Jupyter Notebook model magically becomes a production ready model, even as the model is being served as a REST API endpoint. So this is where the advancement came in. Like you started with the simple VM instance, you started doing it in your laptop. Then people suddenly started talking about serverless, non-serverless, on-premise, cloud, and even Databricks workflows. You can schedule it, so you can write all those necessary tags in Databricks workflows. Even they provided their own orchestration tool so that you don't have to rely on their Azure Data Factory. So everything in Databricks was made hand in hand so that you don't have to look for other solutions.
Yeah.
So that is how my building the data science expertise took a turn. So if I have, since I started with the VM setup and all these things, it in the end it was able to reach it till the cloud version of it. So since you might start with basic Linux fundamentals, and that is like a lifelong skill, right? It will be comfortable with you when you are building it end to end. So this is how all these three different parts, data, infrastructure, and model deploying versioning. So the model versioning is all were possible in ML Flow and Databricks, all went together, and we were able to build an end-to-end solution.
Awesome. Awesome. So few questions. Again, I'm going to your LinkedIn profile and I'm going to look at, say, You just talked about building a serverless, parallel, distributed model, right? On cloud, where you are doing it live. I found out few more terms, doing it live for 20 products, 10 million customers across 3,000 retail and call agents. When you're building a project of this scale, right? What are some of the challenges, if you can reflect on your past experience, what were some of the challenges which you faced that time, which, if it was available today, could have been done very easily? Was there any instance or was there any such cases where this challenge of scale and complexity came into picture?
See, so basically there are two parts to it, right? So one is the basically the scalability issue came in when we were even we were new in 2017. So we were all directly using Spark, and then we were directly deploying it into production. So that was the ideal scenario.
Yeah,
But there is a stoppage to it, right? You can't spin up a VM instance unnecessarily, right? For 20 million customers, if you have to spin up a VM instance and the job should run, you will have to inquire the compute cost, right? So if the
right,
company is not willing to like if there is an extra incur of cost to the company, that's not a good way to approach a problem, right?
right.
So one basic thing we understood is that is where the serverless we started researching about the serverless thing. So
Hmm.
you can build, so for a model training, so you will not going to use all the 20 million customers to build a model, right? You need a
Yeah,
representative population, right, to
yeah,
build your model. So let's take you have only 500K records. So in that 500K records, you are going to build a simple a logistic regression model you have built. Now, this 500K can be done using a Databricks notebook itself. That is self-sufficient
right.
for us to build it. Now, once I am built with the model, now I need to ensure which might be useful to scale it up. So that is where the cost analysis happened. If I use the Vertex AI and the prediction job, let it fire all the compute instances. Let's say I pass the input data set A, I pass the model version, and it is going to automatically scale up and then give you the predictions back and dump into BigQuery. So if it's able to automatically do it, what is the cost associated with that? Versus if I have to pull up a Databricks workspace and then directly transfer the data from BigQuery to that workspace and run all the jobs and then save it back to the data BigQuery. What is the cost incurred? So we did those analysis, and again, there is no hard and fast rule that approach one is better, approach two is better. It all
Correct.
depends on the architect how he wants to consume the end user product, right? So if they are using serverless and the ultimate aim is to show everything in a UI, then the serverless made more sense. And if you are going to use a Power BI dashboard to see all the predictions, then Databricks the instance is sufficient to show run
Hmm.
all the models and deploy it.
Hmm.
So that is where the challenge we were able to understand how the serverless is getting adapted during those days. So because when during the early cloud days, it was also from the cloud providers. So I think we all had those GCP trainings, Azure trainings, right? So it is even the use cases, the quizzes in the GCP is you have been given a compute instance, what a service of GCP you will have to use. Dataproc, Data Studio, you will have BigQuery and thing. So it's like the more emphasis was from the vendor side. So Google had
Right.
emphasized folks to use only certain set of packages. So now it is more developer friendly. If I want to use Databricks, I can use it, right? So during those days, initial readiness, because obviously they will have to market their solutions, right? How all of us do. So
Very much.
that came in. So that was one issue with the infrastructure. That is for sure. So you need to analyze it very clearly. And the second thing is, whenever you are building an ML model, try to have a very base solution. So let's say, rather building it using a deep learning based solution and then getting the stakeholders approval, it's better to have a very simple model which
The
can
baseline
explain all
model.
the feature explainability, and then make sure you get it into production and try all the features as an add-on. that will gain the more trust within the stakeholders. So rather
Understood.
directly attacking the problem using deep learning.
Understood.